Picture this, you're gazing at Neptune, the, uh, the icy giant right on the edge of our solar system. It's just this serene blue beauty. But here's the thing. Neptune harbors a secret, a force of nature, so powerful it would make the strongest hurricane on Earth look like a gentle breeze. We're talking about winds that can reach a mind-boggling 2,100 kilometers per hour. That's supersonic, faster than a speeding bullet. But how can a planet so far from the sun's warmth, receiving only a fraction of the energy we do, generate such ferocious power? That's the puzzle we're going to try to unravel in this deep dive into Neptune's supersonic winds. Welcome to Cosmos in a Pod, the Space and Astronomy series.
Glad to be here.
Okay, 2,100 kilometers per hour. I can barely even grasp that. I mean, it's not like we could just experience a Neptunian breeze here on Earth, right?
Not exactly. To put that speed into perspective, think about the fastest car on Earth, a Formula One racer. They can hit speeds over 370 kilometers per hour. Pretty impressive, but still a far cry from what's happening on Neptune.
So what would be a better comparison then?
To match Neptune's wind speeds, we'd have to jump from the world of race cars to the realm of bullets. A high-powered rifle bullet can travel around 1,200 kilometers per hour. Neptune's winds blow right past that, exceeding 2,100 kilometers per hour.
Wow, that's actually mind-blowing. So we know Neptune's winds are insanely fast, but what's driving this? What's the engine behind these supersonic winds?
Here's where it gets really fascinating. Unlike Earth, where our weather is primarily driven by the sun's energy, Neptune's winds are fueled by its internal heat. The planet actually radiates more heat than it receives from the sun.
So it's like the planet has its own internal furnace.
Exactly. This internal heat, likely left over from Neptune's formation, creates these powerful convection currents in its atmosphere. Think of it like a giant pot of water boiling with heat rising from below and cooler gases sinking, creating this constant churning motion.
That makes sense. But wouldn't the extreme cold of the upper atmosphere kind of work against those convection currents?
You'd think so. But that extreme temperature difference actually amplifies the convection process. The heat from Neptune's interior wants to escape, while the frigid upper atmosphere wants to sink. This creates a powerful tug-of-war driving those intense atmospheric movements.
I never thought about it that way. Okay, so we have this internal heat engine driving the winds. But is there anything else contributing to their incredible speed?
Yes. Unlike Earth, which has a solid surface that creates friction and slows down winds, Neptune is a gas giant. It has no solid surface to act as a brake, allowing those winds to whip around the planet virtually unimpeded.
So it's like a massive swirling atmosphere with no speed bumps.
Precisely. And there's one more crucial factor that amplifies those speeds even further, the Coriolis effect.
Isn't it the same force that influences hurricanes on Earth?
It is, but on a rapidly rotating planet like Neptune, where a day lasts only 16 hours, the Coriolis effect is much stronger. Imagine you're trying to walk across a spinning merry-go-round. The faster it spins, the more difficult it is to walk in a straight line, right?
Yeah, I can see that. So on Neptune, this rapid rotation causes the winds to curve and accelerate even more as they move across the planet.
Exactly. You're catching on quickly. So you have this combination of factors: intense internal heat-driving convection currents, lack of surface friction, and a powerful Coriolis effect, all working together to create those supersonic winds.
It's amazing how all these different forces can work together to create such extreme weather. But speaking of weather, I have to ask about the Great Dark Spot. That was a colossal storm, wasn't it?
It was. When Voyager 2 flew past Neptune in 1989, it captured images of this giant swirling vortex, almost the size of Earth. It was a stark reminder of just how dynamic and ever-changing Neptune's weather can be.
That must have been an incredible sight to see. But wasn't there something strange about the Great Dark Spot? Didn't it disappear?
Yes. When the Hubble Space Telescope searched for the Great Dark Spot a few years later, it had completely vanished.
Vanished. So these massive storms just appear and disappear on Neptune. What causes that?
That's one of the many mysteries we're still trying to solve. We believe these storms are transient features forming and dissipating over time. They might be fueled by upwelling plumes of warmer gas from deeper within Neptune's atmosphere. When these plumes reach the cooler upper layers, they create instability, triggering the formation of these massive storms. But as the plume's energy dissipates, so too does the storm. It's like a cosmic bubble bursting, only on a planetary scale.
That's fascinating. So we've got these incredibly fast winds, giant storms that come and go. What else is going on in Neptune's atmosphere? What's it actually made of?
Neptune's atmosphere is mainly composed of hydrogen and helium, similar to the gas giants Jupiter and Saturn. But what sets Neptune apart visually is the presence of methane.
Methane. Isn't that what gives Neptune its distinctive blue color?
Exactly. Methane absorbs red light, reflecting those blue wavelengths, creating that beautiful azure hue we see in images. It's amazing how a simple gas can have such a dramatic impact on a planet's appearance.
It really is. You mentioned earlier that Neptune is a gas giant, meaning it doesn't have a solid surface like Earth. I've always wondered, why is that? Why are gas giants so different from rocky planets like ours?
That's a great question. It all goes back to how these planets formed billions of years ago. In the early solar system, you had this swirling disk of gas and dust. Rocky planets like Earth formed closer to the sun where it was hotter. The heat drove off lighter elements like hydrogen and helium, leaving behind heavier elements like iron and silicon to clump together and form solid cores.
So the rocky planets are essentially the leftover heavyweights of the inner solar system.
Exactly. Now, further out from the sun, where it was much colder, those lighter elements like hydrogen and helium weren't driven off. They swirled around, accumulating into massive gas giants like Jupiter, Saturn, Uranus, and of course, Neptune. These planets became so massive that their gravity pulled in even more gas, creating these enormous atmospheres we see today.
That makes sense. It's like the solar system had this natural sorting mechanism with the heavier elements congregating closer to the sun and the lighter elements forming these giant gas clouds further out.
Precisely. And because gas giants are predominantly composed of these lighter gases, they don't have a well-defined solid surface like Earth. Instead, their atmospheres just become denser and hotter the deeper you go. It's thought that there might be a solid core deep down, but it's buried under immense pressure and thousands of kilometers of swirling gases.
So it's like a giant onion of gas layers, each one getting denser and hotter as you peel it back. No wonder there's no solid ground to slow down those winds.
Exactly. And this brings us back to those incredible wind speeds. Remember, Neptune's internal heat is driving those powerful convection currents, but without a solid surface to create friction, those winds can just keep accelerating, reaching those mind-blowing supersonic speeds.
It's truly remarkable.
Yeah.
But how do we actually know all this about Neptune's winds? It's not like we have weather stations out there.
Of course not. Our understanding of Neptune's atmosphere comes from decades of telescopic observations and, crucially, from the data collected by Voyager 2, the only spacecraft to have ever flown past Neptune.
Voyager 2, that intrepid little explorer that keeps on giving, what did it tell us about Neptune's winds?
In 1989, Voyager 2 made its closest approach to Neptune, capturing those iconic images of the Great Dark Spot and providing invaluable data on the planet's atmosphere. It measured wind speeds, atmospheric composition, and temperature variations, giving us our first real glimpse into Neptune's wild weather.
So Voyager 2 was our eyes and ears on Neptune? What about more recent observations?
Since Voyager 2's flyby, the Hubble Space Telescope has been our watchful eye on Neptune, continuously monitoring the planet's weather patterns. Hubble has observed the formation and disappearance of other dark spots, smaller storms, and even subtle changes in Neptune's cloud bands over time, giving us a long-term view of this dynamic atmosphere.
It's incredible how technology allows us to study a planet billions of kilometers away in such detail. What have we learned about those smaller storms that Hubble has observed? Are they similar to the Great Dark Spot?
That's a great question. While they are smaller than the Great Dark Spot, these storms are still massive by Earth standards. They tend to be darker than the surrounding atmosphere and rotate counterclockwise, similar to the Great Dark Spot. One interesting observation is that these smaller storms seem to appear more frequently than the Great Dark Spot, suggesting that powerful storms are a more regular occurrence on Neptune.
So Neptune is a planet of constant atmospheric upheaval.
It seems that way, and what's even more intriguing is that these smaller storms often interact with each other, merging, splitting, and sometimes even changing direction.
That must create some incredibly complex weather patterns.
Yeah.
But with all these observations, have scientists been able to pinpoint what triggers these smaller storms? Is it the same upwelling plume mechanism you mentioned earlier?
That's one possibility, but we're not entirely sure. Some scientists believe these smaller storms might be related to instabilities in Neptune's jet streams, those fast-flowing bands of wind that circle the planet. Just like on Earth, where jet streams can influence weather patterns, it's possible that these streams on Neptune are playing a role in the formation and behavior of these smaller storms.
It seems like the more we learn about Neptune's weather, the more questions we have. But speaking of questions, we haven't talked much about Neptune's magnetic field. Does that play any role in all of this?
The magnetic field always a source of intrigue. Neptune's magnetic field is tilted at a significant angle and offset from the planet's center, which is quite unusual. Scientists believe this peculiar magnetic field might be interacting with Neptune's atmosphere in ways we don't yet fully understand.
So another piece of the puzzle. It seems like Neptune is holding on to its secrets tightly. What are some of the other mysteries that still surround this icy giant? We've covered so much ground in our deep dive into Neptune's supersonic winds. It's amazing to think about all the factors that come together to create such extreme weather on a planet so far from the sun. But you mentioned that there are still some lingering mysteries. What are some of the big questions that scientists are still grappling with?
One of the biggest mysteries is the sheer intensity of Neptune's winds. Even though we know the planet's internal heat plays a crucial role, the exact mechanisms behind generating winds of such extreme velocity are still not fully understood. Why are they so strong, especially considering how far Neptune is from the sun? It seems like even with that internal heat, there must be something else contributing to those superpowered winds.
Yeah, that's what I was thinking too. What are some of the theories out there?
Well, one theory is that there might be more efficient energy transfer processes happening within Neptune's atmosphere than we currently understand. It's possible that the internal heat is being converted into wind energy with remarkable efficiency, leading to those incredible speeds.
This is like Neptune has figured out a way to supercharge its wind production.
Exactly. Another mystery revolves around the lifespan of Neptune's storms. We know the Great Dark Spot vanished relatively quickly, but we're still unsure how long these storms typically last, or what ultimately causes them to dissipate. It's strange to think about these giant storms, some almost the size of Earth, just appearing and disappearing in Neptune's atmosphere.
It makes you wonder if there are storms raging on Neptune right now that we haven't even detected yet.
That's entirely possible. And then, of course, there's the enigmatic role of Neptune's magnetic field. We've talked about how it's tilted and off-center, but we still don't have a clear picture of how it interacts with the planet's atmosphere and potentially influences those wild wind patterns.
It feels like every answer we uncover about Neptune just leads to more questions.
That's the beauty of scientific exploration. Each discovery opens up these new avenues of inquiry, pushing us to expand our understanding of the universe. And Neptune, with its supersonic winds and enigmatic storms, is a prime example of how much we still have to learn, even about our own cosmic neighborhood.
You're absolutely right. It's a humbling reminder that we're just beginning to scratch the surface of what's out there. Who knows what other wonders await us in the vast expanse of space?
Indeed. And speaking of wonders, this is just the tip of the iceberg when it comes to the mysteries of our universe. There are countless other celestial phenomena waiting to be explored, understood, and marveled at.
Well, I, for one, am eager to keep exploring. Thanks for taking us on this incredible deep dive into Neptune's wild winds. It's been an eye-opening journey.
The pleasure was all mine. It's always exciting to share the wonders of space with curious minds.
And to all our listeners out there, if you want to continue exploring the cosmos with us, be sure to follow Cosmos in a Pod for more mind-blowing deep dives into space and astronomy. And don't forget to check out our YouTube channel for stunning visuals and further insights into the topics we cover.
Until next time, keep looking up and keep asking questions. The universe is full of wonders waiting to be discovered.